A very good morning to one and all. This is Ven Ahmed, a student of Isabella Thorburn College, class BSc second year, college roll number 205018. Today I am going to present the presentation of mechanics paper. So first of all, what is equilibrium? You know that when a body is supported at its center of gravity, it shows no tendency to turn or rotate, and hence the body can be said to be in a state of equilibrium. The term equilibrium has, however, wider meaning, and this is used even for the body in uniform motion if two or more forces acting on it do not affect its state. Thus, a body is in a state of equilibrium when two or more than forces acting on it do not change its state of rest or of uniform motion. Equilibrium is therefore the state of balance which maintains the body in its state of rest or of uniform motion. The essential conditions for the body to be in equilibrium are the essential condition for a body to be in equilibrium are the resultant of all the forces acting on the body should be zero. The algebraic sum of the moment of all the forces should be zero. When a body is at rest, it is in equilibrium, which may be stable, unstable, and neutral. So let us discuss these cases: stable equilibrium, then unstable, and then neutral. First of all, stable equilibrium. A body is said to be in stable equilibrium if it returns to its original position after being slightly disturbed. Example, a book lying on a table or a cone standing on its base. The second is unstable equilibrium. A body is said to be in unstable equilibrium if after being slightly disturbed it does not return to its original position but tends to move. Example, a stick balanced on a finger, an egg balanced on its longer axis, a cone standing on its apex, a man standing on one leg, a man dancing on the rope. The third is neutral equilibrium. A body is said to be in state of neutral equilibrium if on its slight disturbance it neither comes back to its original position nor moves further but remains at rest in its new position. Now, in other words, you can understand these cases when a body moves on a smooth curve, which is shown in the graph here given below. Then it takes the different positions. It will at rest at point A, B, and C, which are the uniform positions of maxima and minima of the curve. If the body is slightly disturbed from the position of rest, that is at A or C, then it will try to come back its original position of rest. Here, the equilibrium of the body is stable. However, it is displaced from the position at B, then it will try to go further away from the original position. Here, equilibrium of body is unstable. Here we will discuss the case of a sphere whose center of gravity is not at the algebraic center of the sphere. We have the following cases. Case 1. If the center of gravity, that is CG, abbreviated here, lies on the vertical line through the point of contact and it is below the geometric center of the sphere as shown in the figure, and then the sphere is lightly displaced on its tends to come back to its original position of rest. This is the position of stable equilibrium. Case 2. If the CG, that is center of gravity, lies on the vertical line through the point of contact and it is above the geometric center of the sphere as shown in the above figure, and the sphere is slightly disturbed, then it tends to go back away from its original position to the position of rest. This is the position of unstable equilibrium. Now the third case is if center of gravity lies on the vertical line through the point of contact and coincides with the geometric center of the sphere and slightly displaced, when it will remain in equilibrium. This case is of neutral equilibrium. Now, applications of theory of equilibrium on strings. Equilibrium of strings is one such topic you come across almost daily in your life, be it holding your handbag or playing of tug of war with your friends. Just as it easy to visualize, it is equally easy to convert it into a mathematical model and understand the forces that are involved. Let's take an example of a handbag. You use the string of your handbag to lift it and carry it around. Depending upon the weight inside the bag, the amount of tension is the string also varies, and eventually the load exceeds the load carrying capacity of the string. It breaks. To make it more interesting, consider two strings of your bag are of different lengths and the bag is quite heavy, so you take the help of your friend to pick it up, each holding one string. To avoid the bag from touching the ground, you and your friend would be at different distances from the bag, taking your hand level as the reference of the angle made by the string on that reference would be different. Which string according to you would have a heavy amount of tension in it? The string which is at higher angle with the reference, or the person which is closer to the bag would have to apply more force, thus the string that would have more tension in it. Now, what is point-sought central axis? A line through a rigid body which is parallel to the vector sum f of a system of forces acting on the body, and which is located so that the system of forces is equivalent to the force applied anywhere along the line, plus a couple whose torque is equal to the component of the total torque T exerted by the system in the direction f. Thank you.